Hi, and welcome to Founded Learning channel. Today I will teach you everything you need to know about UML use case diagram. So at the end of this video, you will be able to understand what is a use case diagram and how you can build it in a real life scenario. So to do that, we will first explain what is the purpose of a use case diagram, so why we really need it, what is a use case diagram, what are its elements, and we will finish with a practical example. So let's start first by explaining why do we really need to build a use case diagram. Often to develop an application for a given client, it's really difficult to understand what he wants exactly, what are the goals of his app, who are the users, and how they can interact with the app. So the client may think that he explained very well, but actually he may forget some features or the listener may not understand him. So in this case, using a use case diagram is very helpful, as it allows first to manage the general scope of the app by defining the general goals. And also a use case diagram allows you to communicate with the project stakeholders. In fact, it's a great way to communicate complex idea in a very basic way. So let's see now what is a use case diagram. The use case diagram helps to explain how the system should behave by defining the users and the main services offered by the system. It's in fact a high-level diagram that represents the interaction between users and the system. And once your app is developed, use case diagram provides a very simple way for testing system functionalities. Let's get it now on the use case diagram elements. Well, there are four elements in a use case diagram, which are system, actors, use cases, and relationships. We start with the first element, which is the system. A system can be a website, can be an application, a software, or a business process. System is usually represented by a rectangle that include all the use cases. The second element in the use case diagram is actor. In fact, an actor is an entity which is outside of the system that interacts with it. An actor can be, in fact, an external system, a business process, or a person. But you have to pay attention here that an actor corresponds to a role, while the same physical person can be represented by several actors in the same system if he has several roles in the system. For example, a person Jack can use an online shopping site as administrator to manage the site users, but also as customer if he wants to purchase products as well. So here we usually represent the actor with a human shape. There are in fact two types of actors. The primary actors, it's a user that initiates the system. It's generally represented on the left of the system. So the primary actor initiates and uses directly the system, while the secondary actor is more reactionary. If performing a service needed, then it will get involved. The secondary actor is usually represented on the right of the system. Between two actors, we can find one type of relation, which is the generalization. It means that an actor can inherit the behavior of another actor. For example, here we have an actor, a director, which inherits a commercial. So that means that the director can do all the commercials functionalities on the system. We will move now to the use cases, which is the third element in a use case diagram. So a use case is in fact a service given to an actor. It shows the functionality of the system from a user's perspective. Use case name is usually a verb or a noun phrase, and we represent a use case with the circle shape with the name of the use case inside it. Let's get now into the relationships element, which is the fourth element in a use case diagram. There are in fact four types of relationships: association, inclusion, extension, and generalization. Association is a relation between an actor and a use case. It means that actor use the system by doing the functionality mentioned on the use case. So association is a relation between actor and use case. For example, here we have a customer which is associated with use case place online order. It means that the customer use the system by doing this functionality. The second relation is inclusion. An include relation shows dependency between two use cases. It's used to indicate that the source use case always contains the included use case. For example, here we have use case place online order that include the use case login. So it's we cannot place an order if we're not logging into the website. It's always it's necessary for doing this use case. It's an obligation. The third relationship is extension. So here this relationship is used to indicate that the destination use case is not always necessary for the primary use case, but it can be in some situations. For example, the use case consult catalog and the use case add to back. So we have add to back extend consult catalog. So for example, on online shopping websites, you can see the catalog products. If you are interested by a given product, then you can add it to the use case. You can add it to back. So use case add to back is just optional. Okay. So I know that these two relationships, inclusion and extension, may confuse you. So let's see another example to clarify this. We have here a very basic example to help you differentiate between include and extend. When you log in into a website, the system will absolutely verify your login and password. That use case happens every time you log in. But when you log in, sometimes the system might display an error message. For example, if you enter wrong information. So display error message is optional. It may happen and it may not. So we say that display error message extends login. Okay, so to recap this, include relation happen every time, and login and extend the relation happen sometimes. Okay, and please pay attention to the arrow point. In include, the arrow point the included use case, while in the extend relation, the arrow point the basic use case. All right, move now to the generalization relationship. So the generalization or inheritance means that the specific element or the child elements inherit everything that characterizes the general elements or the parent elements. So for example, we have here two specific use cases which are pay by credit card or pay by PayPal that inherit the general use case pay. So they will inherit all characteristics of use case pay, like association with the actors, dependency, relationships, or even already existing inheritance. Okay, so pay by PayPal or pay by credit inherit all what characterize the use case pay. Okay, so let's now practice all these concepts with a simple example. If you still have any confusion about the use case diagram, this exercise will solve all your questions. Here is the exercise that we will do together. It's about building a use case diagram for an online shopping website. So, eBay is an online shopping website specialized in the sale of computer products. The website can be visited by an anonymous person who can consult the catalog, manage his bag, add product to bag, and create account. A customer, after logging in into the system, can place online order, cancel order, or validate his order. The validation of the order requires the payment of the amount of the order either by credit card or by PayPal. The website is managed by an administrator who should manage the website users and also manage products catalog by adding, editing, or deleting products. He cannot do any operation without being authenticated in the website. Okay, so let's analyze this example. We know that we need here three primary actors. The first actor is the visitor, who can consult the catalog, manage the bag, add to bag, and create account. So it's all the services that a visitor can do in a website. The second actor is the customer. The customer can log in into the website, place an online order, cancel order, or validate, and pay, of course, the order by credit card or by PayPal. And the third actor is the administrator. The administrator can log in, manage users, manage products catalog by adding, editing, or deleting a product. Now we will move to Asta UML software to see how we can build this use case diagram for this example. So here is the interface of Asta UML. We will now first create a new use case diagram. Okay, so the first thing to do is to add our actors. So as we say, we need here 3 actors, which are the visitor, the administrator, and the customer. So here is the first actor, visitor. We add the second actor, which is the customer, and of course the admin. Okay, so according to the example, a visitor can consult a catalog, can create accounts, and can manage his bag. Okay, so here we can add the use cases. So I will add the first use case, which is create account. The second is consult and manage bag, and of course he can add product to bag. No, add bag. Okay, so here is the cases or the functionalities that a visitor can do on a website. Now to do a relation between these use cases and the visitor, as we see, it's done by an association. Association is a relationship that relates actor to a use case. So here we can add our association, so the visitor can create account, add product to bag, consult catalog, or manage his bag. Okay, so here are the use cases that a visitor can do on the system. So now we can analyze more these use cases to see if there is any dependency or extension between these use cases. For example, here we have consult catalog and add to bag. So we can do a relationship between those cases, two use cases. So I will delete here this association. So the relation that we can do between these two use cases is an extension. Okay. For example, while the visitor is visiting or seeing the catalog, if he is interested with any product, then he will click and add it to the bag. Okay, so it's an extension, it's not an obligation, it may happen sometimes. Okay, so we will add here the extend relationship, and please pay attention to the point arrow. Always in extend the relation we point the basic use case. So we will do like this. Okay, add to bag, extend, consult, catalog. Okay, so here is the use cases that a visitor can do. We will move now to the actor customer. Okay, so a customer, what he can do in the system. A customer can place an online order. He can manage his bag also. Donc here is manage his bag. So I will add here an association, place online order. Customer can also manage his bag. Customer can also consult the catalog. Okay, a customer can cancel order. Okay, he can cancel an order, and also a customer can validate order. Okay, we'll put it here. Validate order. Okay, and he should pay the amount of the order. Okay, so here are the other use cases. So I will recap. A customer can cancel catalog, manage his bag, place online order, cancel it or validate it, and pay the amount of the order. But on the exercise, it said that to validate order, it requires to do the payment. Okay, so here we will delete this association and we will relate these two use cases. According to the exercise, to validate order, it requires to do the payment. So it's an include relationship, okay, because it's an obligation. We can never validate orders without doing the payment. So I will add here an include relation and always pay attention to the point of the arrow. So we will do like this. Always it point the included use case. Okay, validate order include the pay to the payment. Okay, and it said that the payment can be done either by credit card or by PayPal. Okay, so here we will do a generalization. Okay, so I will add two use cases which are pay by credit card, okay, card, or pay by PayPal. So here it's a generalization or a inheritance between these cases. So here is the specific element that will inherit the generic element, which is pay. Okay, so to do the inheritance, we will use this arrow. Okay, so pay by credit card or pay by PayPal are two use cases, specific use cases of this parent element, which is pay. So that means that two use cases will inherit all what characterize the parent element. Other relationships with actors within include an extension relationship, or even if there is an existing inheritance. Okay. What we forgot the login use case. Also we have so we in the exercise it said that the customer should log in the system, and of course he cannot place an order, cancel it or validate it if he's not log in. So we will add here the use case to log in. Okay, and of course it's the type of the relationship, it's an include. Okay, because it's an obligation. We cannot place an order, validate it or cancel it if we will not log in into the website. So here I will add an include relation, and of course always the arrow point the included case. Okay, so here is the login. Place online order, cancel order, validate order. Always we should log in into the system. And for the two use cases, manage bag and or consult bag, it's not necessary to log in. Okay. And of course, the third actor, which is the admin, can manage users and manage catalog. Okay. So I will add here manage users, and the second is manage the catalog. Okay, and I will add the association between an actor and a use case, manage catalog. And it said in the exercise that managing catalog is done by adding new products, editing products, or deleting. So here we are talking about inheritance. It's these are specific elements of this general element. So I will add here add product, edit product, and of course delete product. And I will add here a generalization between these elements. And of course the the admin also should log in into the system. So I will do here relation between manage and login. It's an inclusion, of course, and here. Okay, to manage users or to manage catalog, the admin should first log in into the system. Okay, so here is my use case diagram. I have here these relationships. Okay, we can see here that these two actors, customer and visitors, do the same use cases: consult, catalog, and manage catalog. Okay, so here we can factorize this behavior by adding, if we want, it's optional, we can add here, for example, another actor that we can name, for example, member. Okay, member. I will delete these associations, these two associations. Okay, the member will do consult, catalog, and manage bag, and of course these two actors will inherit this actor. So I will put here generalization symbol like this. Okay, so it means that the customer and the visitor will inherit the behavior of a member. Okay, and member is in fact an abstract actor. We use it when we have actors that have a common behavior. It represents an abstract role shared between two actors, visitor and customer. And adding this actor is optional. We can keep our diagram without it. It's also correct. Okay, and of course I will add the system boundary here with this rectangular. I will draw the system boundary like this. Okay, I will. Okay, I will repeat this symbol. Okay, so here the system boundary, all what is inside this rectangle is my system. Okay, and here are the actors. As we said, the primary actors usually are represented on the left of the system, and here please we have a secondary actor. For example, for the payment, to validate the payment, the website should contact the bank server to check the card information, if they are correct or not. So to do that, we will add a secondary actor who is the bank server. Okay, who is the bank server. And as we said, an actor can be a person, can be a system, can be a business process. Here we have an actor who is in fact a system, which is the bank server, who will participate in this use case. Okay, so a bank server, why he is a secondary actor? Because he doesn't initiate the system. He's reactionary. When we need it, we will participate. Okay, so it's a secondary action. And for the sample, we can leave this sample as the primary actor, or we can change it. For example, here we can add icon like this. Okay, just to say that it's a system, it's not a human. Well, here is the use case diagram for our practical example. I wish this tutorial will help you to build your own use case diagram. If you have any questions or comments, leave them on the comment section and I will answer you as soon as possible. Thank you and have a great day.